Okay. 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 I think it's time. It's time. Okay. Okay. So hello everybody. This is Luboš Pirkl from CFD Support. Welcome to the webinar on Turbomachinery CFD, which is a CFD simulation workflow for all standard rotating machinery. The test case for today will be a radial fan. Just in case of any technical problems, feel free to contact me in the future, and I will gladly answer all your questions and reminders. The webinar is going to take about 1 hour. In the first part, I will show you how to simulate a radial fan in Turbomachinery CFD, and in the second part, there will be a Q&A session dedicated to your questions and my answers. Feel free to put your questions. I will answer them later in this webinar. And yeah, here we go. So basically, I will share you my desktop and start. Okay, I will switch somewhere to the Turbomachinery CFD. Okay, I'm here now. Okay, shit. This is my. Okay. I didn't have my microphone at the beginning, so I start again. I'm starting again. No, yeah. Okay, so hello everybody. This is Luboš Pirkl from CFD Support, and basically, hi, welcome to the webinar on Turbomachinery CFD, which is CFD simulation workflow for all standard rotating machinery. The test case for today will be a radial fan. Just in case of any technical problems, feel free to contact me in the future, and I will gladly answer all your questions and reminders. The webinar is going to take about 1 hour. In the first part, I will show how to simulate a radial fan. In the second part, there will be a Q&A session dedicated to your questions and my answers. So feel free to put your questions, and I will answer them later in this webinar. So, well, here's the Turbomachinery CFD graphical interface. This is how it looks like. Before we come here, let me start with a brief description what Turbomachinery CFD is. So I will go to CFD support web page to the products in session in menu products. You can click to the first item, which is Turbomachinery CFD, and there you can find many information about Turbomachinery CFD. So what Turbomachinery CFD is? Turbomachinery CFD is a unique software based on OpenFOAM. It was designed for CFD simulations of all rotating machinery, such as fans, pumps, compressors, turbines, water turbines, both radial and axial machines, both compressible and incompressible flows. Let me put just a quick review of its unique value proposal. So we believe Turbomachinery CFD is unique for a couple of reasons. Number one is Turbomachinery CFD has no licensing policy, which means our clients can keep Turbomachinery CFD forever, and they can use it for unlimited number of users, jobs, or cores. It's fully unlimited. Number two is Turbomachinery CFD is fully automated, which means the workflow can be run by a single command or a single click in the graphical interface. The case setup is done. Really everything is automated. So the case setup is done. The computational mesh is created. The simulation is done, and finally the full results report is written down in HTML format, ready for your web browser, ready to check the results. So it's automated. Number 3 is Turbomachinery CFD is open source. That makes it easily customizable to your own purposes, to your company workflow, to your habits, and to your work. Number 4 is the real tutorials are included. So basically, the user has no doubts about the best practice settings. The easiest way to start is to take the tutorial, just replace the geometry, modify some settings, and run the simulation. So it's really complete. There are many other benefits of using Turbomachinery CFD. I'm not going to go for all of them. Feel free to contact me. I will gladly describe all the details. Today I'll go a little bit more general. Yeah, so it's software. I have clicked now the workflow example. So this is quite important. So basically the most important information is all the information is available online. It's available online on our website. So if you read everything, or if you once get oriented, you will really get all the information from the website. I have pasted some major links below to the comments in this webinar, so you can read them, and you can click them in the webinar site on Hangouts, Google Hangouts. So Turbomachinery CFD is available both for Linux and Windows operation system. Turbomachinery CFD is transparent. The trial version is available for free for 1 month period. So anybody can try it. Anybody can make sure it works, and it's so great. And afterwards, anybody can decide to buy or not after he or she has all the information he needs. So in our download section, you can click to download software, and you can download Turbomachinery CFD trial version either for Linux or either for Linux or for Windows. You can try, and you can make sure. Okay, in the downloads, you can also download any like 6 or 7 cases, six of them for Turbomachinery CFD, which is like axial fan pump, radial fan, radial turbine, radial compressor. So today we will deal with radial fan. So you can download the case here directly. Maybe what is also important is there is a PDF which is called Start Turbomachinery CFD, step by step, that is described all those steps to install and run Turbomachinery CFD either in Windows or in Linux. So the point, my point is, all the information is available online on our website. Okay. The Turbomachinery CFD workflow is fully served from the graphical interface. It has its GUI. The graphical interface is the ParaView. I can show you. So those are special plugins and sources for ParaView. I will show you later. You can also work from terminal, like typical OpenFOAM user, but the most people prefer working from graphical interface. So this webinar will be also from graphical interface. Yeah, it's up to you, your decision. Okay, so I will start with today's case. Maybe I'll go back for a while. I'll go back to the web page, and I can show you the case study of. Okay, it's not okay. It's here. So this is short study, Radial Fun CFD study, and this study shows basically what is done, what's in the background of the process. So there's a Radial Fun, which is designed in software, CF Turbo. I will speak about this in a minute. The surface model has to be created, just a CAD model or surface model. And yeah, and here's the process, which is automated. So the mesh is created, the simulation setup is done, and okay, here we go. Simulation is being run. Finally, when the simulation is finished, it's automatically evaluated. And what's really important is the results report. For each simulation, the results report is created automatically. So basically what you do in practice is you check the results report all the time. I can show you. So for example, this test case is, I guess this one is finished. Okay, so yeah, so once any simulation is finished, you can check its report, which is really detailed. There's many information about the statistics, all of them, flow rates, residuals, also the efficiency, perhaps the most important feature of each rotating machinery simulation, how it's developed in time, how it's doing compared to the flow rate, also the torques, total pressures per interface or overall, velocity, magnitude, different angles, and this is the report. Okay, so we have the fun tutorial here. You can download it on our website. The aim of the fan designer is always hunting the pressure ratio and flow rates and torques, and which they create the efficiency together. So finally, the efficiency. What is important at the beginning all the time is the each Turbomachinery CFD simulation has its surface model and configuration file. So the inputs are surface model. I can show you. So this is the okay. So this is the surface model of the fan. It's basically three-dimensional geometry, and what is also important is there's a configuration file. It's a single file. It's a single plain text file where all the important information for simulation are written. So there's always the configuration file and the surface geometry. Yeah, when starting new simulation, you can write your configuration file from scratch, or the most effective way is to modify an existing tutorial case from your case to your case you want to simulate. You can just replace the geometry and modify the settings, and you can go. In this interface in ParaView, you can open the TCFD file, which is the configuration file with the extension .tcfd. And once you open it, you can edit everything in here. And also you can start from the scratch, but I wouldn't recommend to start from the blank screen and write everything. I recommend always the most effective way how to simulate anything in OpenFOAM or in Turbomachinery CFD is to take some similar case and modify it to the case you want to simulate. So anyway, all the settings can be done in ParaView. You can just write everything down. So what's your machine type? What's your coordinate system? What's the axis of rotation? What are your geometry parameters? What are physical settings? Gravitation, viscosity, density, reference pressure, reference temperature, heat capacity. Yeah, then you specify how many speed lines you want to simulate, what are their rotation speeds, how many points each of speed line to simulate, and of course then the boundary conditions for each speed line for each point, each single point you want to simulate. So this radial fan has total pressure at the inlet, the boundary condition we called outlet vent, which is special boundary condition which drives the static pressure at the outlet corresponding to the flow. You specify the resistance here. You can specify number of processors you want to simulate. You can first or second order. You can specify all many details. What is important? You can there are surface geometry files specified here and many mesh settings. The important thing is the meshing is automated. So we use our Turbomachinery CFD uses snappy hex mesh, which is great meshing tool. Once you learn how to work with it, what to do all the settings, then it's okay, and it's okay because we have it automated. Okay, so that's the configuration file. You can write it here in the settings. You can also save it. You can save it, and yeah. Okay, yeah. The surface model. The surface model is simple CAD model in STL format. It can be combined from multiple components. Any number of components is allowed. There can be inlet tube, outlet tube, the volute, impeller, etc., etc. Each component should be waterproof, and ideally it should be fitting vertex to vertex, and the STL file. This particular model of radial fan was designed in CF Turbo. Maybe I can show you a little bit what CF Turbo is. CF Turbo is special software for rotating for design of rotating machinery. The CF Turbo, now I'm in CF Turbo. Now I'm showing you CF Turbo software. It's created and developed by German companies, CF Turbo, located in Dresden and Munich, and it's really great. It's simply great design tool for simulating for design of rotating machinery. So it's really smart. It's ease of use, very effective tool for designing machines. So your STL model has to be born somewhere, and if you don't have one, just consider CF Turbo because it's really great tool. You can input all your settings. You can input your formula. You can input your CAD data just to optimize them, and yeah. So basically, the surface model has to be created, and it is created, and for these here in CFD support we use CF Turbo because we think it's a really great tool. And what is important, CF Turbo has its interface. It can write in Turbomachinery CFD format, so you can do easily export all the case, and then you load it in Turbomachinery CFD and just simulate. So it's ease of use, and there's common interface from CF Turbo to Turbomachinery CFD, which is our simulation tool from CFD support, and we can, yeah. So again, the point is there's the configuration file. I can show you one, for example. Yeah, so I can show you the configuration file, how it looks like. So for example, this is plain text file for Radial fan. We are going to simulate today. It's simple, really, just a few of parameters are specified because the rest is can be default. And then the surface geometry, which has to come from somewhere, and from some CAD and or from some design software like CF Turbo. Okay, so so there's the setup in the settings, and once I'm satisfied with my settings, or once I've done my settings, I use TCFD Manager, which is a special plugin, a special filter for ParaView that creates this GUI we are in. Then so the TCFD Manager is a special filter where you handle the simulation. Maybe I will show you in another window. Okay, this will be better. Okay, so here you specify what's your configuration file, what's your directory name. You can write the case, and then if you click the run all, the automated workflow starts, and it gives you all the information you need. For example, which speed line is simulated, which point is simulated, how much time is remaining to the for the point or to the end of the whole simulation. What is really important, you can update your report anytime. So I am in my first speed line in my point number 3, and like 40 minutes or 37 minutes are remaining to finish the simulation. But during the simulation, I can update my report, clicking update report, and I can see my current results. So yeah, so I can look into my report, and I can see I can see how the flow rates are converged at the inlet and at the outlet. What are the residuals? What are the efficiencies, at least of those first 2 points, and how is developing the third one? I can see the torques, and again, how is the last one developing? You can see the total pressure, total pressure difference, which is the power produced by the machine. You can watch total pressure per each interface, every component, hence its inlet and outlet. So you can watch the total pressure, for example, at every interface, what's coming in, what's coming out, every component. or the whole machine. Everything is plotted in graphs. The same with velocity magnitude, the average velocity at each interface, and also the angles, the circumferential and meridional angle at each interface is measured. So you have really good overview of what's happening during the simulation. What you can do, once you would be satisfied with the results, you can say abort and write, for example. So the simulation can be skipped to the next point or aborted any time, and you can go on with the results you got in the meantime. Okay, so this was just a general overview. So yeah, the graphical interface is really comprehensive. You can watch everything. You can do the visual analysis, like for example blade to blade or meridional average. You can watch the mesh, for example. I can show you the, yeah, these are the simulation results. Okay, maybe I can show you. Yeah, this is the measurement. This one is not good. Okay, I can show you with solid color. So this is the computational mesh. You can check it many times. You can always get back to change the settings, do the process again, and compare the results, for example. Yeah. Okay, I will take a look if there are some questions. Yeah. So let me take a look if there are some questions. I can't see any questions here. Okay, so I can't see any questions. Okay, then I can go back to my simulation, and okay. So again, so I will repeat just a little bit. So there is the how do I start? There are the inputs. So the inputs to the Turbomachinery CFD, those are surface geometry and configuration file, and they come from the user. The user has to create the configuration file and surface geometry. The configuration file is open, can be opened in ParaView, and here in ParaView you can edit it. You can edit any feature of it. So really all of them, all the physics. Also, the surface model is here represented by the links to the real STL files. Here you can specify here all the points or the speed lines, boundary conditions, physics, and also the mesh settings. And then you can simulate. The simulation is automated, so you just apply the TCFD manager, which is a filter which is basically the library for ParaView, and there you can write the case, and you can go one by one. You can create the mesh, you can run the calculation, you see how much time is remaining to the end of the simulation. You can skip to the next point, you can abort the simulation. Anytime during the simulation you can watch the results, and watch the report of results. So the report, maybe I can say a little bit about the report. So okay, it comes back. Okay. Anyway, the report is like consisting of integral values. So there are no colored pictures. There are efficiencies, flow rates, residuals, torques, total pressures, per interfaces, or overall circumferential and meridional angle. So those are integral values in the report. There is also, by the way, the report is in HTML format, which can be read by any browser and any mobile device. Of course, you can watch the like colored pictures or the flow results. You can watch, yeah, basically all of them. So you can click the analysis in ParaView. So you can check uh, what's the pressure. Okay, what's the, I don't know, perhaps velocity. Uh, uh, what is important? Turbomachinery CFD includes a special set of tools which is called Turbo Blade Post, and it allows special turbomachinery post processing. So maybe I'll show you in the web page. So well, yeah. So part of Turbomachinery CFD is the Turbo Blade Post, which is a special set of plugins to enable special Turbomachinery CFD post-processing, like visual. So you can view the meridional average and blade to blade and those similar analysis. So I'll go back to my case, and for example, yeah, I can show you. So I can, yeah, take my case, and I need to have internal mesh, just the internal mesh, and I can say the filter, which is called meridional average. I can click on it, and it shows me the options. I can say, okay, I'd like to have like 100 points of the resolution. That's okay. So I keep the default options. I say apply. And this meridional average shows me what are the average values plotted in the meridional plane, averaged into the meridional plane. So it's here. This is surface distance, which is perhaps nothing, but this is how my total pressure is distributed and averaged in my machine, or any other value like velocity, for example, or I don't know, relative velocity, for example. Okay. Yeah, I'll check if there are some, whether there are some questions. Okay, okay. I can see a question of Ahmad Saeed Fafzal. I'll select it. I hope you can see it. Do the software have selection on turbulence model and other equation selection? Actually, I have to switch to me, but that would be the best thing, I guess. Okay, so no, uh, not yet. There's no his camera. Is there camera? Okay, it's me. Okay, hi. Yeah. So no, by default there's a K omega SST model with its standard settings like 5% of turbulence at the inlet, uh, and for omega something something typical. And no, you can in the graphical interface you can't select the turbulence model. It's easy to do that, but it's not yet available in the graphical interface. So it's possible in the command line just manually. You can create your case, then you switch to K epsilon, for example, or to some low Reynolds or something model, and then you run the simulation. That's okay. But in graphical interface you can't. And yeah, this is the same. So the graphical interface has some options. There are many of them, but not all of them. And those options that are available in OpenFOAM, you can do manually, but not in graphical interface. Okay. Okay, I can't see any more questions here. So, well, again, I believe this is it for today. I promise I will answer all your questions. Just send me a question. I will answer all of them. So all those questions and requirements are special many times. So send me an email. I will answer you, and we can make or we can make special call just face to face, just one to one, and make everything clear. So everything is transparent. You can download anything. All the information is available online. I think that this is important. So for now, I would say thank you for your time. And yeah, see you next time. See you soon. So yeah, bye.